Hello everybody, welcome to goal number 9. For this goal, what we're talking about is simplifying rational polynomial expressions. Let's break that down. Rational means that it's a fraction, polynomial means what we've been doing, and expressions means there's no equal sign involved. So it's just like basically taking a simple fraction and reducing it. So let's review really quickly the stuff that we learned in P4-P5. Some basic rules for simplifying. If we look at the first one up here, we have 5x squared y to the fifth over 25xy. This is a straightforward simplifying problem. But what I want you to notice is that there's no pluses or minuses between any of this. And because there's no pluses or minuses, this is basically just straight multiplication taking place, and we can reduce things top to bottom. So when we look at this then, when we have 5 over 25, that's just going to reduce to 1/5. When we take the x squared and x, since there's 2 x's on top and 1 on the bottom, if we reduce, there's only going to be 1 x left on the top. With the y to the fifth and the y, since there's 5 on top, 1 on the bottom, there's only going to be 4 y's remaining on the top if we simplify. And that's it. We are officially done simplifying that problem. Real quick, real painless, real easy. Look at letter B. Same principle here. Notice, again, there's no pluses or minuses between any of these, which means this whole thing is one monomial, just one term, and this is one term. Just like this one was one term and then one term on the bottom. So when we go to simplify this, again, we could simplify top to bottom. This is negative 10 over 30, which is negative 1/3. We have x to the fifth. There's no x's to simplify, so it's going to stay at x to the fifth. Y to the 0 power just becomes 1, so we can pretty much just cross that out. And then on the bottom, that y to the 9th has nothing to simplify with. So this is our simplified answer. Nothing more we can do with it. Now notice this was very easy to just simplify. But we're going to add a few components to this now. First thing we're going to learn about is something new. It's called domain restrictions. What domain restrictions are is essentially what we're saying is I cannot divide by 0. When we have fractions, you are not allowed to divide by 0 because if you divide by 0, it becomes undefined. So what we're going to be looking for in each of these problems is what value can the variable in the denominator not equal? Because if I put that value in there, I would have a 0, and we can't divide by 0. So if we look at the original problems we just did here, this x right here, and again, we're only focusing on the denominator. This x right here cannot equal 0. Because if this was a 0, this would be 25 times 0 times y, and that would all equal 0. So this whole thing would be divided by 0. And we know we can't divide by 0. For this value, y cannot equal 0. Because if this was 0, this would be 0 times x and times 25, which would also be 0. So we can't divide by 0. Same idea for letter B. Y to the 9th power. Again, y can't equal 0 because 0 to the 9th power is 0. 30 times 0 is 0. We can't divide by 0. So you get the idea of what it means when we're saying divide by 0. Now, let's apply it to what we're doing in this unit. These, you'll notice, are a little different than the warm-ups we just did. Notice now that we have signs in between these, pluses and sometimes minuses. These are no longer monomials. These are binomials and trinomials and whatever else we might have. What that means is I don't have the luxury of simplifying just straight top to bottom like this because what's happened is this is now grouped together. This is not an x and this is not a 3. This is together an x plus 3. So we have to treat it as a binomial, not a monomial. This is not an x squared and a 12x and a 27. This is a trinomial. This is stuck together as an x squared, a 12x, and a 27. So what we're going to do is we're going to factor each one of these and see if we can reduce them. So look at your numerator. X plus 3 doesn't simplify. So let's just leave that as an x plus 3. However, my denominator, now this is where you're going to have to go back to your checklist. It's a trinomial leading coefficient of 1. So what we're going to ask is what are the factors of 27 that add up to 12? That just happens to be x plus 9 and x plus 3. After you've factored the whole problem, it's at this step that you have to determine any domain restrictions. So what are we going to say? Well, right here, we're talking about the denominator. What can x not equal? And what can x not equal right here? If you think about this, if I was to put in a negative 9 plus 9 would equal 0. So if I had a negative 9 in there, this would be 0 times x plus 3. 0 times anything is just 0. So I wouldn't be able to divide this problem out, and so x cannot equal negative 9. If I was to put a negative 3 in here, I would have negative 3 plus 3, which is 0. 0 times this would equal 0, and the whole thing would be divided by 0, which is undefined. So these are our domain restrictions. If you want to work through and solve them, you can actually just say x plus 9 cannot equal 0, because if this whole thing here was equal to 0, this whole thing would be undefined, and then just solve, you would get the same thing, that x cannot equal negative 9. Okay? But I'm sure you guys can kind of mentally go through and do them. So now how do we go about actually simplifying this? Well, you'll notice that on the top and the bottom, we have an x plus 3 and an x plus 3. If they have something in common, let's cancel them out. Because they're identical to each other as binomials, we can get rid of them. Unlike if a monomial was taking place, we couldn't get rid of it. That leaves us with nothing on the top. And because nothing's left on the top, we're going to put a 1 there. And for the bottom, we just have an x plus 9. This is our final simplified answer, along with x cannot equal negative 3 and negative 9, because you have to state your domain restrictions. Okay? There's not a whole lot to these. It's just a matter of going through all the steps to do them. So let's try a few examples. I've got several more here because this is challenging. So this is a long video. Feel free to pause it and jump ahead and do practice problems on your own. So here's letter B. Trinomial. Look at the top one. There's no leading coefficient, or it's a leading coefficient of 1, which means the factors of 24 that add up to 10 are going to be x plus 6 and x plus 4. For this one down here, we're going to be able to take out an x, and that's going to leave us with an x squared minus x minus 20. This is a trinomial leading coefficient of 1. So that means that we can factor that even further, and we're going to have an x plus 6 times x plus 4 on top, x times the factors of 20 that add up to negative 1 are negative 5 and positive 4. At this point, now that's completely factored, let's state our domain restrictions. Here we have an x, here we have an x, and here we have an x. Here, x cannot equal 0, because 0 times all of this would just equal 0. Here, x cannot equal 5, and here, x cannot equal negative 4. So those are your 3 domain restrictions. Now we can go ahead and simplify. Top to bottom, we have an x plus 4 in common. X plus 6 does not simplify with anything on the bottom, so there's nothing else we can get rid of. Remember, this is an x. This is not an x. This is an x plus 6 because it's grouped together. So that means our final answer in this problem is going to be x plus 6 over x times x minus 5. And x cannot equal 0, 5, or negative 4 if we were to try to solve. Okay. Onward to example number 3. Okay, as much as you want to, you have to resist trying to cross these out because they're identical. Remember, this is not a 2x squared. These are not by themselves. Because we have pluses in here, this is a trinomial. So group it as a trinomial. Determine first if there's a GCF. In this case, there isn't. Same thing with the bottom one. So that means we just have to go through and factor it using our other methods. Doing the top one here, leading coefficient is not equal to 1. So that means we're going to do the bottoms up. The factors of 30 that add up to 13 are going to be 3 and 10. We're going to divide by 2. Simplify each. First factor is going to be 2x plus 3. And then the other factor is going to be an x plus 5. Do the same thing for the bottom one. Let's go ahead and try to do our bottoms up because the leading coefficient is not 1 and it's trinomial. That means we're going to have 23 on top, 60 on the bottom, and the factors that add up to 23 are 20 and 3. Divide them all by 2. and we reduce, and this is equal to 10. So this, we end up with 2x plus 3. Here we end up with an x plus 10. Now that we've gone through and simplified them, let's determine the domain restrictions since we can't factor any further. First one here, we get that x cannot equal. Actually, let's try to set this up. 2x plus 3 cannot equal 0, which means that 2x cannot equal negative 3, which means that x cannot equal negative 3 over 2. Same thing here, x plus 10 cannot equal 0. That means that x cannot equal negative 10. So those are your two domain restrictions in this problem. Let's go through and cross out things. These two are in common from the top and bottom. Again, when you get to this step right here, a lot of people look at these and say, oh my gosh, I can cross out the x's, and I can take 5 over 10 and reduce it and make it 1 over 2. But remember, this is not a 5 and an x. This is an x plus 5. It stays as a binomial. So there's nothing else I could do with that to simplify it, so we leave it as x plus 5 over x plus 10. X cannot equal negative 3 over 2 or negative 10. This is our final answer there. Okay, two more examples. Start off, see if there's a GCF. There isn't. Leading coefficients equal to 1. So what are the factors of 18? We get x plus, what do we have, 6 and 3. And on the bottom, same thing, factor it out. The factors of 12 that up to 4 are going to be 6 minus 2. The domain restrictions here are going to be x cannot equal negative 6 and x cannot equal 2. Simplify top to bottom. These cancel. And the only thing then that we're left with is x plus 3 over x minus 2. And x cannot equal negative 6 or positive 2. There you go. Oops, sorry. Here's your answer. All right, and last one. Sorry this video is so long, you guys. I just wanted to make sure you had examples to go through with. Again, let's try to factor. So we're going to do bottoms up for this one. I'm going to save the trouble of actually going through the whole bottoms up. We get 2x, x, 5 and 1, minus and plus. On the bottom, we have 2x and x, 5 and 1, plus and plus. Okay, so this is the factored form. If we work through and solve for each x, on the bottom we get that x cannot equal negative 1 over 2. And here, x cannot equal negative 5. So then the simplified form for this, let's get rid of anything top to bottom we can. So 2x, whoops. Can't simplify that because these are not the same. We have a 2x plus 5 and this is an x plus 5. And so what we notice is that 2x plus 5, let's see, 2x plus 1, yeah, there's nothing that we could simplify. So unfortunately, I just crossed off something we weren't supposed to, but the simplified answer for this is just going to be 2x plus 5 times x minus 1, 2x plus 1 times x plus 5, and x cannot equal negative 1/2 or negative 5. Sometimes that happens where you just can't simplify, and that's okay. All right, so there's your answer. Sorry, I was zoomed in a little bit there. Hope this helps. Sorry it was so long. Look forward to working on the next goal, which is a little bit more challenging. Take care.